Good day, everyone. Welcome to Quantitative Methods with Simulations and Modeling. And let me give you a recap of what we had discussed previously. We discussed about an introduction to supervised machine learning. And at the same time, we talk about the introductory part of regression. And then with this, we continued on discussions about linear regression, multiple regression, logistic regression, and at the same time, the classification and regression tree. And now I'm going to introduce to you another model for machine learning, specifically on supervised machine learning algorithm. And this is a different, what do you call this, algorithm than the one that we have discussed previously, wherein they belong to regression family. This time, we'll be talking about the J48 algorithm. Okay. J48 algorithm is very, very popular, especially in the field of clinical studies and among others because of its high prediction rate. In the model is very simple and very easy to understand and implement. Right, so let's start with what is the J48 algorithm. Okay, as I was saying, J48 algorithm or the C4.5 is one of the most widely used machine learning algorithms to examine categorically and continuously what is good or differ from this algorithm than the one that we have talked about previously is that the target variable or the dependent variable is the categorical variable that is in text, in words, okay, not in numbers. Okay, and as I was saying, this J48 algorithm is derived from a C4.5 algorithm. Okay, they are the same in nature. Okay, C4.5 algorithm actually is a classification algorithm which produces decision trees based on information theory. And it is an extension of the work of Ross Kinland's earlier ID3 algorithm, also known as in WECA as J48, or J stands for Java. So it is inspired using Java programming language. The decision trees generated by C4.5 are used for classification. And for this reason, the C4.5 is often referred to as a statistical classifier. And the C4.5 algorithm for G48 is mostly used among many fields for classifying data. And for example, interpreting the clinical data for the diagnosis of coronary heart disease, as an example, or classifying e-governance data from and many more. So G48 algorithm is actually a machine learning decision tree classification algorithm based on iterative dichotomizer tree or ID3. And the J48 algorithm is used to classify different applications. And the platform, accurate results of the classifications. And J48 algorithm is one of the best machine learning algorithms to examine the data categorically and continuously, as I was saying a while ago. As you can see here in this diagram or in this particular tree, it's an example of what we can do for a J48 algorithm. Okay, previously we discussed on how we split on decision trees, such as in CART. We are using the Gini impurity for that matter. And in G48 or C4.5, we have two stages of splitting. We have the entropy. Entropy is defined as the randomness or measuring the disorder of the information being processed in machine learning. And an entropy is an information theory matrix that measures the impurity or uncertainty in a group of observations. Now it determines how a decision tree chooses to split in data. And further, in other words, we can say that entropy in the machine learning matrix that measures the unpredictability or impurity in the system. We are looking into how impure the data or the data sets of a given, database or we have. Okay, so consider, for example, a data set with an n classes. So the entropy may be calculated using the following formula, wherein E stands for entropy. E is equals to minus the sum of p sub I log 2 p sub I, where I is equals to 1 to n. And p sub I is the probability of randomly selecting an example in class P. So that is how we arrive entropy. And so entropy is very, very important in calculating the information gain. So the second stage here is on the information gain. So information gain is actually a measure of how much information a feature provides about a particular class. So if the other one, if the entropy is about impurity, determining impurity, pure data sets, this time we are looking into on how much information a particular feature provides about the class. And information gain helps us to determine the order of attributes in the nodes of a decision tree. Now it can help us actually determine the quality of splitting as well as, we shall soon see that in the demonstration. The calculation of information gain or IG should help us actually understand the concept better later on. Now, the information gain may be calculated using the following formula, where gain is equals to E sub parent minus E sub children. So the term gain represents information gain, and E sub parent is the entropy of the parent node, and E of children is the average entropy of the children node. And so as a result, you will have your information gain calculations. And then from there, you will have, by combining the first and the second procedure, you will have the splitting of your data to become a decision tree until such a time that you arrive the least. Okay, and meaning to say the leaf node will have a value of 1 zero type of data. Okay, so that's all for the J48 algorithm, and I would like to acknowledge the following references that we have used in this lecture. Okay, so we have from Machine Learning Mastery website, section websites, the Digital Vijaya websites. Okay, so we have demonstration time. I think let's have our demonstration. Okay, so here we go with us have this our studio to demonstrate all this the how we create a decision tree in using J48 algorithm in our programming. Okay, so this is our environment. So open our studio with our programming on it. Okay, so first let us try to import our database. We will still be using the all this the data sets that we have been using previously. Okay, the salaries. Okay, and the default will be under here. So our target variable is the professor, and the rest of the variables here will be our explanatory variables. Okay, so again, let me reiterate what is good with J48 is that it accepts a mixture of data types or variable types. It accepts with words or words in categorical values and in characters in the categorical values, and then continuous variables or even categorical variables that are represented by numbers. Okay, so we will be at this point we will be using this. Okay, by the way, while I was continuing this, I would like also to inform everyone that J48 is a non-linear type of algorithm process and non-linear values. All right, so by looking here, we have about like 397 observations with 6 variables such as rank, discipline, years in PhD, years in service, sex, and the salary. And we already agreed that our target variable or our independent variable is the rank. This is the one that we're going to predict, right? So let's create a new script, right? So from there, since salary is very low, I'll be using the variable that will handle all these the data sets. Okay, so it's now in T. So first thing to do is to load our libraries. So what are the libraries that I'm going to use? So we're going to use library CA tools. Now, if you don't have this library, all you have got to do is to go to the tools, then click install packages. And then from there, you just write here CA tools, and then click OK if you're done, and you wait until it is successful. Okay, since I have already that in my computer, I don't need anymore to install that. Okay, so let me run it. Okay. So then let's have another library that we'll be using. I'll be using the R Weka. Okay, and then we have here the party kit. Library. I'll be using the R part and the R part locked. So we have loaded already our libraries. The next thing to do is to look into our data. Let's try to look the structure of our data. All right, so as you can see here, rank is a character, and actually it is categorical with these values here. Discipline is also in characters as A and B. In the years in service, character actually is a category but supposed to be it's male and female. So we are going to convert this into a categorical value by using factor function. Okay. So we have here the rank as our variable, still using that, and the factor function, the rank. Okay. Then let's copy that twice. This one is for the discipline, and this one is for the variable sex. This one is for the discipline. This one is for the sex. Okay, let's run that. And let's go back again to check the structure. Okay, there you go. So our rank now is a factor with 3 levels, such as associate professor, assistant professor, and professor. And for our discipline, we have 2 factor levels. We have A and B. And for sex, we have 2 levels, such as female and male, respectively. All right, so we have already our converted the factor. I mean our character values or variables into a factor. Now we're gonna have to split our data. The other one is for training purposes, for development of the model, and then the other one is for testing purposes. Okay, so for randomizations and the results, so we'll be using set3. Okay, then let's say, for example, our sampling for this matter, for the splitting of our data sets, I'll be using some variable that will handle our sum split function. So we have here sample split function from CA tools. And then initially, since our target variable is rank, so I'll be using rank as our reference. And then we will be using the split ratio of functions or methods under a sample that split the functions. And then here, 80% will be our training data set. And the rest of the 20% will be our testing set. Okay, so I will be creating a variable that we handle for the training data set, okay, it is a subset of our main value with our sum for the splitting. It's true. And then for the test, the same subset of p and sum is equals to false. Okay, seeing it correctly. Oops. Subset for a while. Sorry, it's a wrong spelling for the false. Very wrong. Okay, so we are able to split the two. Let's try to look into the dimension of our data in our train. Right, so there are about like 318.6, 318 data sets for our training data sets for our model development with 6 variable. And for our test data sets, we have 79 data sets for testing purposes with still 6 variables for that matter. Okay, next thing to do is to create a model. So we will now create a model. Since this is a J48 algorithm, so let's just have a new variable. Let's say, for example, RJ48. That's our variable for variable that will handle the model. Okay, and then I'll be using the J48 function from Weka, our Weka. And again, rank is our target variable. Okay, and then the data that we'll be using is coming from the train data set. Right, and then let's try to check our RJ48 data. Okay, there you go. Okay, so we have here our pruned J48 pruned tree. So it says here that the root node, as selected based on our entropy and information gain, we have about like years in PhD is less than or equal to 11. If it is true, then it will come in here. If it is false, it will go here. Okay. Then, if years in service is less than or equal to 5, then you are predicted to be an assistant professor, right? So you have there are 55 data sets that belongs to assistant professor. And if your years in service is greater than 5, then you are predicted to be an associate professor. And 20 of those data are correctly classified, and 2 misclassifications here, 1 is misclassifications here. All right, so if your years in service is greater than 11, if it is true, then years in PhD is less than or equal to 11. Then years in service is less than or equal to 5, then you are predicted to be a professor. Okay, there are 5 correct classifications. However, there are also 1 misclassifications here. And then years in service is greater than 7, then you are predicted to be an associate professor with 14 correct classifications and 3 misclassifications, and so on and so forth. So you'll notice here the number of leaves here in our tree is 8, and the size of tree is 15. Okay, let's go furthermore. Okay, let's try to visualize this in a decision tree. Okay, so we'll display it over here. So to do that, we will try to require some functions as the party kit. Okay. Quietly true. And then we will plot. Okay. Plot our RJ48 the model. There you go. So this is our model as representative of this pruned tree. Okay, so let's try to see in a better view. So we have here years in service. Is it less than or equal to 11? So years in service, if it is less or equal to 5, then you're predicted to be over here assistant professor. That's how your graph here. Over here, you are predicted to be an associate professor. We're here professor, over here associate professor, and so on and so forth. So this is now the representation of our pruned J48 pruned tree. Okay, so this is now our model. Okay, this is the J48 prune tree. Okay, the other one over here is our text-based J48 prune tree. Okay, so let's go back to our source code. Okay, let's try to look into the summary of our model. Okay, so we have here RJ48 as the model. There you go. So in this case, let's try to read the values. Okay, that is generated. According to the result of the summary, it says here that there is 94.0258% correct classifications or correctly classified, with about like 299 instances out of 318, if you could remember. Okay, and then incorrectly classifications, there are about like 19 datasets that are incorrectly classified. So in this case, it is about like 5.9748%. In terms of inter-rater reliability of the data that we have there, the gap statistics is represented with about 87.79% inter-rater reliability. It's very, very reliable. The data is very reliable. And in terms of the confusion matrix is here. So this is our actual, and this one over here at the top is our predicted. So A is denoted as our associate professor, B is for assistant professor, while C is for professor. So how do we read this confusion matrix? Okay, so it says here that A over A here. So 38 means that there are 38 out of 318 datasets. There are 38 correct classified as associate professor. However, there are misclassifications, such as one classified as supposed to be an assistant professor, but they are associate professor. At the same time, there are 5 misclassification and classified as associate professor, but they are supposed to be a professor. All right. Then we have here another correct classification. There are 53 correct classification or classified as assistant professor. And there are 2 misclassifications, and they are predicted to be an associate professor, but they are classified as assistant professor. Here at the bottom, there are 208 correct classification as professor. However, there are 11 misclassification, and they are classified as associate professor. Okay, so that's how we read our confusion matrix. Okay, so you will notice here, this is the correct classifications. Outside are the misclassifications. So these misclassifications represents the precisions and recall in terms of sensitivity of our data. And from there, we can calculate the true positive rate, the false positive rate, and then true negative rate, and the false negative rate. Okay, so that's our data here. Okay. So how let us try to do some predictions on this example. Okay. Obviously, I will be using a variable here for predict. I will be using P, and we will be using the predict function from stats. Using again our model to predict the RJ48 model, and we will be using now the 20% data, which is the test data. Okay. Let's try to see what happened to P. Okay, let's print. There you go. So the first data, it is predicted to be professor, second associate professor, third professor, and so on and so forth. In this case, 7, 8, 9, 10, 11th, it is predicted to be an assistant professor. Now, using again the model that we have generated, which is in the J48 RJ48 variable model, and this is our model. Okay. All right, so going on, let's try to check the summary of our predictions. Okay, so in this case, there are about like 14 associate professors is correctly classified as predicted, based on the pruned model or J48 prune tree model, or in this decision tree model that in the graphical presentations. And also there are about like 15 assistant professors that are predicted to be assistant professor, and there is another 50 predicted to be a professor, a full-fledged professor. Okay, let's try to look into the data from the 318 data as its probability. Okay, by using the predict function, I'll be using the RJ48 model, and the type of this is the probability, right? So look at here the 318 data sets. Let's try to look into the first few rows. All right, so here in the first row, it is really predicted to be a professor, 100%. Also here. And here we have, it is predicted in the third data set or third respondents. It is predicted to be an assistant professor. Okay, for here, whereas here it is predicted to be an associate professor. And here, predicted to be an assistant professor, the same thing here and here, right? Whereas in the 11th, it is predicted to be an E professor. Okay, so I hope that you learned something today. That will be all for the J48 algorithm. Okay, thank you very much for listening.